So this is the first lecture of the CS61 class, and this is Boolean functions, right? And the first thing we're going to do for every single one of these sections is we're going to have a little lecture on some terms and definitions and symbols that you need to know. Because a lot of math, what makes it hard is the particular vernacular and symbols that it uses, and the definitions. As English speakers, most of our definitions are kind of like loose, right? So this is a blue shirt. You might have a shirt that's a very different color that's still blue. And we understand what that means because as human beings, we are sense-making machines. Our brain makes sense of the world around us. So, you know, we've had to interpret different shades of blue for many years, and we get that. But when we're talking about math, we can't be general like that. We have to be very specific in our definitions. So blue means a certain, you know, there's a certain color content that is blue, and nothing else is blue, only that. So by the same token, the first thing we want to do in every one of these segments is kind of lay down our definitions that are going to be used throughout the rest of the section. So what we're going to start with is sets. Right, got my marker here. So what is a set? Well, a set is, in its most basic sense, just a grouping of symbols, right? So 1, 3, 5. That is a set. We often shorthand a set by using an uppercase letter and just saying A equals this set. Now, you've worked with sets, you know, your whole mathematical life. You just might not have realized it. When you're talking about whole numbers, right? Remember talking about whole numbers when you were in school? That's a set of whole numbers. When you talk about the alphabet, that's a set, right? It's a set of all the characters we know as an alphabet. And it's a different set depending upon what country you're from, or whether you're using Unicode or ASCII, right? Or any of those. Those are all different sets. But at their core, it's just a set. It's just a group of symbols that we've decided that belongs in this set. If we want to talk about a particular example from the set, we would say something, we would indicate it like this. We would have a lowercase a, and then that symbol that kind of looks like a euro, and then the name of the set. So this says A is a variable that exists somewhere within uppercase A. And it's also very standard if you give your set an uppercase letter to represent the set, you use a lowercase version of that letter to mean within that set. So if you, again, going back to if you were talking about, you know, traditional algebra, you would say things like x, right? X within, and then you would have whatever symbol you'd chosen for all integers or all positive integers, depending upon what you were doing. And the same thing applies to programming. So in Java and C++, when you defined, for example, a variable, right? You defined it as an int. You are saying what set it belonged to. It belongs to the set of all integers. If you defined it as a positive integer, or in Java like a big int, those are slightly different sets, but they all, you know, there's a finite number of them, right? That's the key thing about a set. There's a finite number of possible entries. All right. So our set A is 1, 3, and 5, and lowercase a exists within A. All right. We could define another set. Let's define another set because we're awesome. Let's say that we have a set B, and let's say that it equals 2, 4, and 6, right? And then we might write B exists within uppercase B. Make sense so far? All right, so we got our two sets, A and B. From that, we would define a function, f, and traditionally you put a little curly Q on the f when you do a function. I don't know why. f of a, and sometimes you'll see an equal sign here, equals b. Sometimes you'll have a arrow. I don't like that the book is actually a little inconsistent on this. Just know that they mean the same thing in this case. And what this means is f of a results in b. Right? That means whatever our function does, if you give it an input from set A, right, because A is within A, the output will be within set B. That's what this means. What does that mean for this function? What does this function do? Does whatever we want it to do. We can define it however we want. You could say that the function is a plus 1, right? And then 1 plus 1 is 2, 3 plus 1 is 4, 5 plus 1 is 6. So that could be our function, but we could map it any way we want. And you'll often see it portrayed like this. You'll have 1, 3, and 5, and then you'll have 2, 4, and 6. And then, brand new pack, just for you guys. You're welcome. We could define that 1 maps to 6, and 3 maps to 2, and 5 maps to 4. We could just define that. We just decide that. This is what it maps to. Math is all about, traditional math is all about finding the rules for how things work. But when we're talking about a function, we define what that function does. Okay? And very important, name some more terms I want you to know. This is the domain, and this is the range. All right? So the input to our function is the domain, the output of our function is the range. Sometimes it's called a codomain. I always thought that was stupid. Why use the same domain? But mathematicians like to define things weirdly. We're going to call it domain and range. All right? And this is very relatable to what you were doing in programming, right? With Java or C++. So if you created a function that would, take, for example, a character and then output the integer value of that character, right? So the domain is the ASCII character set, and then the range is all integers, or really all positive integers, right? Up to 16,000 or 256, depends on which domain you had. But that's a totally normal thing you would do. So this is directly applicable to the stuff that you did in programming. All right? So the terms that I really want you to get from this section: a set, right? A set is just a grouping of symbols. We assign meaning to them, right? And we're going to talk about number systems later on in the next section. But that's a meaning we assign. Sets don't have meaning by themselves. It's just a set, just a group. Within, that funky E, right, means this exists within the set. It's some value within the set. And a function, which is a mapping from one set to another set. They can be the same set, right? For example, square, right? Multiplying the same number by itself. The input is going to be all integers, and the output is going to be all integers, right? So the mapping is the same. The sets are the same for both the domain and the range. That is very possible. In this case, they're two different sets, right? Does that make sense? Okay. So let's go on to the next section. So knowing what we know about domains, ranges, and sets, let's talk tuples. Tuple is another one of those terms you need to know. You've actually experienced one version of the tuple, a particular use of it, in the couple. A couple is a two-tuple, right? So if you're thinking about a, let's see, I'm going to go back to black. If we go back to, like if you're talking about XY coordinates, right, you might have 5 and 7, right? That would be your, is that in the ranger? 5 and 7, right, would be a two-tuple or a couple, right, a pair. Or you might have, you know, if it's three-dimensional, 5, 7, and then on the z-axis we'll have 13. By the way, in general, when you're talking about a set or a grouping where it could be any of the values, you use the curly braces. And if you're talking about a specific chosen value, you use parentheses. That's, in general, the way you do things. You might see slightly different notation in different books, but we're going to stick to that. All right? So this is a 2-tuple. This is a 3-tuple, right, which leads us into the n-tuple. So if we have something that looks like this, f of x sub n, ooh, I forgot the colon there. Sometimes instead of parentheses for a function, you'll see a colon. And then 0, 1. What the hell does that mean? Okay. This is saying we're defining a function, and it's an n-tuple, right? An n-tuple. And all the values come from the set 0 and 1. Why didn't we define a set the same way we did just 2 minutes ago? Because for Boolean, you often just write the whole set out like this because it's a short set. It's only 0 and 1. Boolean is always 0 and 1 or T and F for true and false. Boolean, there are only 2 values. So we often write it out. Don't ask, we just do. So this is saying that there's some n-tuple, right, from 0 to 1. And we would write that as x1, x2, x3, all the way down until you get to xn. To make this a little bit more concrete, right, if I was to give you a specific example and I wrote, say, f of x3, so we're going to do a 3-tuple, and then 0, 1 is our set. An example of that would be 0, 0, 1, or 1, 0, 1. So both of these are examples of this function definition. Okay, makes sense? Everybody with me? Cool. Now, usually when you define the function like this, we have this arrow, which again could be the same as an equal sign, but we say the arrow goes to 0 or 1, which means for every n-tuple, there is an output which is a 0 or 1. What does that mean? Well, that means for our example here, we might say that 0, 0, 1 maps to 1, and 1, 0, 1 maps to 0. But for our specific example here, right, for x to the third, right, the 3-tuple, for each 3-tuple, we have to define an output, which is going to be a 0 or a 1, right? And this is exactly what we do when we use truth tables, which is what we're going to look at. Excuse me. A truth table is all the possible 3-tuples if it's a 3-column, or 4-tuples if it's a 4-column, or however many tuples there are, with one output for each, which is what we're going to talk about in the next segment when we talk about truth tables, and also is exactly what we do when we start building circuits, which we'll do a little tiny bit later on in this class. All right? So, key things I want you to remember from this segment. A tuple is just a grouping of values from a set. In Boolean algebra, there are always groupings of 0 and 1, right? And we use n to indicate whatever our limit is, the highest number, right? Whenever you see n, just know what that means. And when we say x to the 1, x to the 2, x to the 3, in this case, we're talking about column 1, column 2. So you could actually think of this as an array, right? This is an array of Boolean values, 0 or 1. That's what this function is defining. If you give me an array of n number of Boolean values, I will output a single 0 or 1. So hopefully that made sense. If you have any questions, ask them below in the forum. Remember, you get extra credit for asking questions, and you get more extra credit for answering fellow students' questions. Okay? All right. And I will see you guys in class next week.